Hello everyone. I'm going to talk about causal reasoning in humans and comparing it to large language models in a very specific case of chains versus common cause. So imagine that you are a rational agent, and then you have three different pills, and they both like three of them would lead to the effect B with the same probability. So the difference is that the first one, which we call the direct cause, is actually directly would lead to the effect of interest. The second pill, it's a common cause network. So on top of effect B, you will also have effect A. And the third one is a chain network. So there's a prior cause for the drug to be activated. So we know that the last two networks, the chain and the common cause, they belong to the same Markov equivalent class because the joint probability would be calculated identically for both of them. And given that node A and B would be independent of each other given node C, then again, if you're a rational agent, the perception of the likelihood of the effect of these drugs condition on C, condition that you took the drug, is basically similar, like identical for all of these pills. But humans, they are not rational. And I'm going to show you the prediction of the different models that we have in the human psychological research in terms of the difference between this perception of C, like the effect of C on B, again, given that that we conditionalize on C. So on the vertical axis, you see the likelihood, which is the effect of C on B from lower to higher. And on the horizontal axis, I'm going to show you the predictions of the different models, which I cited here, but I'm going to explain this in more detail in the poster presentation. But here you can have an overview. And as you can see, there's conflicting evidence, and researchers basically are all over the place. So the first goal of my study was to replicate the previous ones and to see which one was the case. The second goal was to actually query the same questions from the LLMs. And the reason for that was to see that if LLMs, in terms of causal reasoning in this very specific case, are similar to humans or to rational agents. And I think this is important both for the cognitive science society, because we humans interact with the world. So it's not that we just rely on language in order to understand causality. But it's interesting to see if language data would be sufficient to introduce these human biases in causal reasoning in large language models. It would be also interesting for the artificial intelligence community, because it seems that LLMs can talk causality, but they are just causal parrots. So they cannot really understand causal reasoning. And prior research also showed that not only that they show these sort of biases, but also suboptimal rather than like in comparison to humans. And this is also important for the applications of AI, because many of these reasoning tasks, they are really relevant to medical domain or legal domain that we use like causal reasoning. And we will be in big trouble if these models are not really rational in terms of violating the normative criteria. So I'm going to show you the human experiment data, and this is from the point of view of a participant. So imagine you are the participant, and then we asked the participant three different questions from three different contexts. The first one was economy context, the second one, the alien context, which was very, very abstract in order to reduce the prior beliefs. And the last one, which was sort of moral, was introduced by us. So that was to control the context dependency. And then we had the between subject manipulation, which was the structure of the causal network that I described earlier. This is just one example of one of these networks. So we can see the text here, greater profit for criminal organization leads to criminalizing sex work on the one hand and higher gender crime rates on the other. And then the participant were asked about like his or her opinion on a scale of 1 to 100 about the likelihood of the greater profits for the criminal organization that would lead to higher gender-based crime rates. We asked the same question from the LLMs, but we also changed the query in a way that it only produced numbers, not text. So I'm going to show you the human data. These are the participant sample that we have. And on the vertical axis, you can see the likelihood score, horizontal axis, the different conditions. And these are the distributions related to each condition. And you can see that the chain condition is actually perceived as more potent in comparison to the direct cause and the common cause, which is in like similar to what we predicted in the mechanism hypothesis and we registered earlier. So we see this boost in chains, which is this violation of the normative criteria. And this is something that was robust across different contexts. Okay, so the LLMs, we queried on GPT 3.5, GPT 4, and Luminous, which is a German model. And here I'm going to show you the difference between two different distributions, the distributions of the common cause and the distribution between the common cause and the chain. And the metric that we use is Wasserstein distance or earth mover distance if you're from the computer science discipline. And this is I'm going to show you the plots for human data and also LLMs. For the LLM, we also change some other hyperparameter like the temperature I'm going to show here, but in the poster we can discuss others like top P and top K of the model. So on the vertical axis is the Wasserstein distance. If you're a rational agent, this distance would be 0 for you. And then on the vertical axis, you can see the annealing or the temperature of the model. And here different plots for different models and also the human effect. So let's see the human effect first. So this red line that you can see here is basically the Wasserstein distance between the two distribution of the chain and common cause, which means that that humans are irrational. This is something that we previously saw in the behavioral data. But interestingly, what you can see here is that when you increase the temperature, all models that we investigated, they converge to the human data. And by increasing the temperature, we are increasing the stochasticity of the sampling. So this is the finding that if you are interested, we can discuss more in the poster presentation. This is the comparison between the two different plots, the human and the large language model. So you can see that they both showed a similar boost in the chain. And the conclusion would be that the structure of causal events is an essential factor in causal reasoning. So human participants and LLMs, especially at higher temperature, they consider intermediate cause in the chain as more potent than the common cause or the simple direct causes. And the most intuitive explanation for us for this effect was that the middle node is actually perceived as mechanism that connected this cause to its effect. And I'm going to discuss this further. So I want to thank Tobias Gerstenberg from Stanford, my collaborator, Babak Hemetian from Beckman Institute, and Moritz from TU Darmstadt machine learning group. And if you're interested, you can download the data with this QR code and also see the registration of the experiments. So yeah, thank you everyone.